Welcome to my channel Mechanical Classroom. This is the second part of Module 4. In the last class we were discussing about the basics of dynamics. In today's class we will be discussing about D'Alembert's principle. D'Alembert's principle is one of the most important principle in dynamics. This is basically based on Newton's second law, that is F equal to ma. We can simply state D'Alembert's principle as net force in the direction of motion equal to mass into acceleration. Now let's take one application of D'Alembert's principle. Consider the motion of lift. Here this is the lift. This is the lift, and we can see cable is attached to the lift, and the tension in the cable is T, and we can see weight of the lift is marked as W, and the direction of motion is shown as upward direction. Now we are applying D'Alembert's principle in this particular problem. According to D'Alembert's principle, net force in the direction of motion is equal to mass into acceleration. So what is the net force of this system? Net force here is T minus W. T minus W. That is what written here. Why T is written as first? It is positive value. It is positive value as it is along the direction of motion. So it is treated as positive. And W. Why W is negative? W is negative because it is against the direction of the motion. So T minus W equal to W by G. W by G is nothing but mass into acceleration of the lift. Then we can rearrange the equation to find out T or what is asked in the question. Now let's consider when the lift is moving in the downward direction. Figure is same, but direction of motion is in downward direction. So we are applying D'Alembert's principle in this case. According to D'Alembert's principle, net force in the direction of motion is equal to mass into acceleration. So here we are writing W first since it is positive. We have to write positive value first. Since W is along the direction of motion, it is positive, and the tension is against the direction of motion of the lift, so it will be negative. So W minus T equal to W by G, which is mass into acceleration, and we can find out tension as shown in the slide. Now let's do one simple problem. A body of mass 50 kg is being lifted by a lift in an office. Find the force exerted by the body on the lift floor when it is moving with a uniform acceleration of 1.2 meter per second square. So let's write given data. We have given mass of the body 50 kg, acceleration as 1.2 meter per second square. We have to find out force exerted by the body on the floor when it is being lifted. First of all, we have to draw force diagram. So we have to draw first of all a lift, then body of mass 50 kg, and we have to mark a direction of motion of the lift, which is upward, and also acceleration is 1.2 meter per second square. Now let's apply D'Alembert's principle. What we have to find out here is F, that is force exerted by the body on the floor when it is being lifted. Then according to D'Alembert's principle, net force in the direction of motion is equal to mass into acceleration. So what is net force in the direction of motion? Here we have two forces, that is force F acting in upward direction and mass or weight acting in downward direction. Weight is acting in downward direction. So we'll be writing F as F first since it is positive value. Okay, so F minus mg. Why mg is negative? Since it is against the direction of the motion. Okay, so mg will be negative, which is equal to m into a. Substituting the value, you will be getting force exerted by the body on the lift as 550 Newton. Now let's do another problem. In a factory, an elevator is required to carry a body of mass 100 kg. What will be the force exerted by the body on the floor of the lift when the lift is moving upward with a retardation of 0.8 meter per second square, B moving downwards with a retardation of 0.8 meter per second square. So first of all, we can write given data. Mass of the body is given as 100 kg, acceleration as minus 0.8 meter per second square. Why minus come? Since we have given retardation. Yeah, minus sign is due to retardation. So A equal to minus 0.8 meter per second square. Now what to find out? We have to find out force exerted by the body on the floor. Now let's draw the force diagram. We have a elevator with a body of mass 100 kg. We have to mark the direction of motion as upward. Also acceleration is 0.8 meter per second square. When the lift is moving upward, according to D'Alembert's principle, net force in the direction of motion equal to mass into acceleration is F minus mg, which is equal to ma. And here we are rearranging, since we have to find out F m into g plus a. Since a is negative 0.8, a negative will come, and finally answer will come as 900 Newton. Now second sub question is the case when the lift is moving in downward direction. Let's draw a force diagram. We have elevator, we have a body of mass 100 kg. Lift is moving downward direction with retardation A equal to minus 0.8 meter per second square. Now what we have to find out is force exerted by the body on the floor of the lift. According to D'Alembert's principle, net force in the direction of motion equal to mass into acceleration. That is mg minus f equal to ma. Why mg? I am writing first, since it is positive value. Since mg is in downward direction, direction of motion is also downwards. So mg will be writing first mg minus f. Why f is negative? It is against the direction of motion. So f will be negative. Mg minus f equal to mass into acceleration. You substitute the values so that we will be getting force exerted by the body on the floor of the lift as 1060 Newton. Now let's do another problem. An elevator is required to lift a body of mass 65 kg. Find the acceleration of the elevator, which could cause a force of 800 Newton on the floor. First of all, write given data. Mass equal to 65 kg, force equal to 800 Newton. Acceleration of the elevator is to determine. Okay, first of all, draw force diagram. We have elevator and a body of mass 65 kg, and we have to find we have given force exerted as 800 Newton, and it is also given motion is in upward direction. What we have to determine is acceleration. Here also same procedure as previous one. Apply D'Alembert's principle. According to D'Alembert's principle, net force in the direction of motion equal to mass into acceleration. That is F minus mg equal to ma. And substituting the value, we'll be getting acceleration as 2.5 meter per second square. Now we can do last problem. An elevator of mass 500 kg is ascending with an acceleration of 3 meter per second square. During this ascent, its operator, whose mass is 70 kg, is standing on the scale placed on the floor. What is the scale reading? What will be the total tension in the cable of the elevator during the motion? So given that as mass of elevator, we are taking mass of elevator as capital M, which is 500 kg, acceleration 3 meter per second square, mass of operator 70 kg, which is taken as a small letter m. Now let's draw the force diagram, and this one is a lift and this is the cable, and this is the weight of the elevator, m equal to 500 kg, capital M equal to 500 kg. Then we have body inside the elevator. Mass is given as 70 kg, and the direction of motion is given in upward, and acceleration is 3 meter per second square. We have to determine force F, that is scale reading. Scale reading is represented by F. Also, we need to determine this tension. First of all, we have to write what to find out: scale reading F and the total tension. So we can find out scale reading. In order to find out scale reading, we need to consider this portion. This portion, the reading in the scale is dependent on the mass 70 kg and this acceleration 3 meter per second square. It is independent of mass of the elevator. So we need to consider only this portion. Okay, we are applying D'Alembert's principle: net force in the direction of motion equal to mass into acceleration. So we'll be getting F minus mg equal to ma. Substitute the value, we will be getting F as 896 Newton. Now, second part of the question: total tension in the cable of the elevator. In order to determine tension, total tension, we have to consider the whole system. We have drawn here the force diagram, and there things are marked. Now let's apply D'Alembert's principle: net force in the direction of motion equal to mass into acceleration. Here first you write positive value. T is positive since it is along the direction of motion. Then we have mg, weight of the elevator. It is acting against the direction of motion, so it is minus. Also body, whose direction is also against the direction of motion, so it is negative, which is equal to mass of the whole system. Mass of the system is m plus m into acceleration. Now you substitute the value, you'll be getting total tension in the cable as 7296. Okay, hope you understood the problems which we discussed. We will be doing some more problems on D'Alembert's principle in the next video. Thank you for watching. Subscribe and share. Also press bell button so that you won't miss any newly uploaded videos.